Welcome students. Today we are going to study about chapter 3 matrix of class 12th maths. I'll just brief you about what we are going to study in this chapter. The first one will be introduction, in which I will explain definition and notation of the matrix and order of matrix. In the next part, I will explain about types of matrices and their subtypes. And the third part will be properties of matrix. Under that, transpose matrix and symmetric and skew matrix we will be studying. In the fourth part, I will explain you about important points or identities of the chapter. In the fifth and sixth part, we will discuss some numericals or example based on the chapter. And in the sixth part, I will give you some questions related to exercise 3.1 of the chapter. And also, I'll be explaining you how to solve those questions. So let's begin with the introduction part. So first is definition and notation. A matrix is an ordered arrangement of numbers or same quantities in which these are written in rectangular or square configuration of rows and columns. So you can see the example over here. These numbers 1 2 3 4 or 1 2 3 4 5 6, all these are arranged in some sequence, in some order. Okay, so their arrangement and quantities are numbers, right? They are constant terms, so these elements are of same quantity. Okay, like 3 rows and second row is also 3, so they are in rows and columns, they are arranged. So this is called definition of matrix. This is what a matrix is. The elements can be real numbers or complex number, polynomials, and even general functions. It can be anything about these. Okay, generally we denote matrix by the capital letter. Okay, for example, here I have mentioned A or B. So A and B, these capital letters denote the matrix. Okay, let's move on to next. Order of matrix. A matrix having m rows and n columns is called a matrix of order m cross n. That means these many rows will be there in the matrix and these many columns will be there. N usually is unknown quantity. So we can put 7, 8, 9. I mean, it depends on what type of matrix it is. So if there is any value of m and n, then that many elements will be present in the matrix. Okay. So here A, capital A denotes the matrix. So we'll discuss about what it is. I mean about the elements. So first one is A11. A to the subscript 11 or 11 to the subscript A. So it denotes the first element of first row and first column. And A12 is the element of first row and second column. Likewise, A21 denotes element of second row and first column. And A22 denotes second rows and second columns element. So the general form of matrix is given above, this one, where A11, A12, AMN are all elements. In general, Aij is an element lying in ith row. That means the element lies in the ith row. I can be 1, 2, 3, anyone. And jth column, jth can be any column. So Aij, see here, Aij represent that ith row and jth column that will have some value. So generally this matrix is represented by this. A is equals to Aij and the order is m cross n. That means number of rows m and number of columns n. Okay. Next we'll move on to types of matrices. First one, row matrix. A matrix having only one row is called a row matrix. Example is given over here, 1, 2, 3. So we can see that only one row is there, but there are 3 columns, that is 1, 2 and 3. So I, that is number of row is 1 and j, number of row is 3. Sorry, number of columns is 3. Next is column matrix. A matrix having only one column is called a column matrix. Here we can say that only one column is there, but number of rows are 3. So I can represent that number of rows I is equals to 3 and column j is equals to 1, right? Next is 0 or null matrix. As the name indicate, it indicates that the elements of the matrix will be 0, right? So here in the matrix, all the elements will be 0. It doesn't, I mean, depend on how many rows are there, how many columns are there. The only thing is the element should be 0. So number of rows is 2, it can be 3, 4, 5, anything, and number of columns can also vary. But the elements should be 0. That is why it is known as 0 or null matrix. Let's move on to next. Square matrix. A matrix in which the number of rows equals the number of columns is called a square matrix. That matrix in which number of rows and columns are equal, but it is not mentioned that the elements should be equal. Here you can see in the example, elements are not same, but number of rows, that is 1 and 2, number of rows are 2 and number of columns are also 2. So we can say that a matrix in which number of rows and columns, if they are equal, then it is a square matrix. Clear? Next, diagonal matrix. A square matrix is called a diagonal matrix if all the elements except those in the leading diagonal are 0. Leading diagonal in the sense, in this matrix, if I draw a diagonal like this, or in the given example like this, the elements are non-zero in leading diagonal, but other elements, see here, top and below, both the elements are 0. So in the leading diagonal, the elements are non-zero. It will have some value. Apart from that, the other are 0. Clear? Only in the leading diagonal, there will be non-zero elements. But apart from that, in the top and bottom of the diagonal, the values will be 0. The elements will be 0. Let's move on to next. Scalar matrix. A diagonal matrix in which all the diagonal elements are equal is called a scalar matrix. In the previous one, let's move on to back. See here. In this example, 1 and 5 in the diagonal matrix, it is not equal. Clear? Whereas in the scalar matrix, the diagonal, these elements which are in diagonally placed, they are equal. That is 5. So, scalar matrix is that matrix in which diagonal elements are equal. Okay? Next is unit or identity matrix. Similar to scalar matrix, unit or identity matrix have diagonal elements as 1. They will be equal 1. It cannot be 2, 3, 4, 5. No. If it is 2, 3, 4, 5, then it becomes scalar matrix. But if the diagonal elements are equal, that is equals to 1, then it will be unit or identity matrix. Let's move on to next. Triangular matrix. Triangular matrix has two types, that is upper triangular matrix and lower triangular matrix. See here, now you will be confused why triangle have come over here. Because the elements in the matrix will form a triangle and based on that it is named. Okay, so let's talk about upper triangular matrix first. A square matrix in which elements below the principal diagonal are 0 is called upper triangular matrix. That means, see here in the example, this diagonal and this 5. If I draw a line from 1 to 9, 9 to 5 and 5 to 1, then it will form a triangle, right? Below that the element is 0. So that matrix in which the upper diagonal elements are non-zero but lower one is 0 is called a upper triangular matrix, means the triangle is upside. And in the lower triangular matrix, the lower portion of the matrix, that is the elements in the lower section, will be non-zero or they will form triangle, but the upper portion will be 0. Clear? So that is upper triangular and lower triangular matrix. Let's move on to next. Now comes properties of matrix. There are two types of properties. Number one is transpose of matrix. Number 2 is symmetric or skew matrix. Let's talk about first one. If A is any matrix, capital A is any matrix, capital A, as I have already told, the matrix will be denoted in capital letters. Then the matrix obtained by interchanging the rows and columns of A is called transpose of A. That means whatever is there in the row of this, you can see the example 102. If it is changed into column 102 like this, then it will be a transpose, like 534 row, that becomes column 53 minus 4 over here. 386 here, that becomes column 380, like this. So this is called transpose of matrix. It is denoted by A dash or A to the power capital T. Clear? Now next, move on to symmetric and skew matrix. So number 1 is symmetric matrix. A square matrix A is called symmetric matrix if A is equals to A to the power T. That T stands for transpose of matrix A. This matrix transpose is AT. Okay. Now suppose A is equals to these 4 elements are there. That is square matrix it is, right? 2 minus 3 minus 3 4. So row is 2 minus 3, that has become column 2 minus 3, and minus 3 4 has become column minus 3 and 4, like this. So we can say that A is equals to AT. That means it is a symmetric matrix. There is no change. No change in the sense, even though my row has become column over here and the second row has become second column over here, still it is identical. Even after transposing, both the matrices are similar or identical to each other. That is why it is called symmetric matrix. Clear? Second one is skew matrix. A square matrix A is called skew matrix if transpose of A is equals to negative of matrix A, means minus A. For example, A is equals to this 0, minus 2, 2 and 0. Okay. So transpose of this A is equals to 0 minus 2 becomes column over here 0 minus 2. 2 0 becomes 2 0, like this. But before that, see here, it becomes minus sign over here. There is a minus sign with the matrix. So that is called skew symmetric matrix. Even though matrix is similar, but you can see the diagonals. The minus 2 over here became positive, and here positive 2 became minus 2 over here. This minus sign is not considered, okay? But you can see the elements in the diagonal, okay? The positive became negative and negative became positive, okay? So this is skew symmetric matrix. Let's move on to next. Important points to be remembered. Now see here, every element in the principal diagonal of a skew symmetric matrix is 0. In a skew symmetric matrix, every element in the principal diagonal is 0. So for AT is equals to minus A, the condition is. Now if two matrices A and B are compatible for addition and multiplication, then we will use our associative and commutative properties like that. So here we have used the properties. You can just have a look on these properties and how they are named after that. Okay. So here K represents any scalar quantity. Okay. K represent any scalar quantity. And if A be a square matrix, then A plus A to the power T, that is transpose of A, is a symmetric matrix. A minus A to the power T is a skew matrix, and AAT and ATA are symmetric matrix, and similarly A to the power T and to the power T is equals to A. These are the properties that you need to remember. Last but not the least, every square matrix can be uniquely expressed as the sum of symmetric matrix and skew matrix. If we do the summation of both the matrices, symmetric matrix and skew matrix, then we will get this. So A plus AT, just now we have discussed, it is a symmetric matrix, and A minus AT, that is skew symmetric matrix. Okay. So when you do that, you get a square matrix. Okay. So let's move on to the question answer now. Now there are some example based on matrices. So let's go with the first example. Here A be a matrix of order 3 cross 5, that is M into N is given 3 into 5, and R is the row matrix of A. Then determine the order of A. To find out the order of A, first we need to understand the order of A given over here. So 3 into 5, that is M into N, order of matrix is already given here. A has 5 elements in each row, means there are 3 rows and 5 columns, but in each row how many elements are there? That will be 5, right? For example, 1 2 3, 3 rows, 5 columns, 1 2 3 4 5. So in each row there will be 5 elements, right? So we can say that the order of matrix A will be, one row will have 5 elements, that is 1 into 5. Clear? Let's take second example. Construct a 2 cross 3 matrix A is equals to Aij, whose elements are given by this. So Aij stands for, I is ith element in the row and jth column. Ith row and jth column. So Aij is equals to 2I plus j, it is given, right? So I and j can have any number of elements, or the value can be anything. So if I want to obtain 1 a11 a12 a13 depending on the type of matrix, now order is already given, that is M is equals to 2 and N is equals to 3. So it will have 2 rows and 3 columns. So I can understand that if my first element is A11, second element A12, third element A13, because there are 3 columns. And in the second row A21, A22 and A23. So all these elements will be needed. So how many elements are there total? 2 plus 2 plus 2. Total 6. 3 into 2. 6 elements will be there in this matrix, right? So how to find out the elements? Now see here. In first element, that is first row and first column, A11, if I place 1 in place of I and 1 in place of j, correct? I's value is 1 into 1 and 2 because there are 2 rows, and j's values are 3 because there are 3 columns. So if I want A11, that is this one and this one, Aij, A11 will be, I had to place 1 in place of I and j in place of j, I have to place 1. The 2 plus 1, it becomes 3. My first element became 3. Similarly, if you put the values in place of I and j, you will be able to get all the elements, and the final matrix will be, this is first part A11, that is 3, then A12, that is 4. From here we got the value, and so on. You can place in the form of matrix. So this A is equals to the value given in the elements will be your final matrix. Similarly, for the second part of the question, if I place the values 1 2 3 and so on like that, so after doing the squaring of these, because square is given, I square minus j square, so when I solve it, I get 0 3 minus 3 0 and minus 8 minus 5. So that will be your final matrix. Let's move on to next. Now I have given questions related to exercise 3.1. Okay, question number 2. It says write identity matrix of order 4 cross 4. That means there will be 4 rows and 4 columns. Okay, but it says identity matrix. That means only the diagonal part will be 1. I have already explained you what is identity matrix. You can go back to the video, to that portion where I have explained, if you have not understood, and check the diagonal here. All the values, all the elements of the diagonal here is 1, correct? So this matrix is identity matrix of order 4 cross 4. Clear? Now question 3, it has given k plus 4 as the first element of this first matrix, and minus 1 3 k minus 6, that is equals to a minus 1 3 minus 4. In the question it says find the value of a. We need to find out the value of a. Now as both the matrices are equal to each other, so their elements will also be equal to each other. That is, a is equals to k plus 4, minus 1 is equals to minus 1, and minus 4 is equals to k minus 6, and 3 is equals to 3. That is given. So what we need, we don't want this 3 and minus 1 over here, because they both are same, so we don't want that. We want the values with variables a and k. Okay, so a is equals to k plus 4 and minus 4 is equals to k minus 6. If I solve these two equations, I will get the value of k first, and after putting that in k's place, I will get the value of a. So I have given here in this answer. So first of all, this equation, second this equation. After solving, we get the value of k, and that value is put in the first equation, so you get the value of a as 6. Now question number 4 says, what are the possible order of matrix having 6 elements? If the matrix has 6 elements, so what are the possible orders? That 6 elements can be placed in these forms. Number 1, there can be 6 rows and 1 column. Correct? So it becomes m into n, that is 6 into 1. Or there can be one row with 6 columns, so it becomes 1 into 6, 2 into 3, 3 into 2. So these four are the possible order of matrix with the 6 elements. Clear? Let's move on to the next. Now these type of questions are also important. Construct a 2 cross 2 matrix. A is equals to aij, where elements are given by aij is equals to 2i minus j upon 3i plus j. Clear? You have to do same thing. If you want a11, a12, a13 like values, means you want each and every element, then you need to place the value of I and j. Okay, so in place of, if I want a11, then I will use I and j as 1 1. After solving, I will get the value as 1 upon 4. a12 0, a21 3 7. Likewise, if I keep on solving, I will get the matrix as this. The required matrix will be this. Similarly, for the same question, a second part, you get the matrix. So this is how you are going to solve the questions based on the matrix. I'll come up with the next part also with exercise 3.2 and related questions. And also there are some important points before that exercise that also I'll be explaining in the next upcoming video. So wait for that video and keep me updating if you have any issues with the questions, or you can just get back to me, write in the comment box in this video and if there's any issue, you can get back to me. Also try to solve other questions related to exercise by yourself. Thank you and have a good day.